Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be doing 6.4, which is solving equations with variable exponents. There are multiple ways to do this assignment. Now that we've covered logarithms in Math 2 and Math 3, you should be able to use those, but these examples are going to go back to the Integrated Math 1 textbook. So you can solve these ones specifically without using logarithms, but if you're comfortable with logarithms, then I would recommend using that method. But because we're doing a little bit of review from Math 1, we're going to use the method that does not involve logarithms. If you need a review on logarithms, be sure to watch the appropriate video. So for 6.4, we are looking at solving equations with variable exponents. Most of these are fairly straightforward. So if I have something like 2 to the x equals 16, and if I'm trying to solve this without using logarithms, then the goal is to make the base the same on both sides so that I can set the variables, or the exponents rather, equal to each other. So in number 1, I want to write 16 as 2 to some power. A lot of people can do the mental math on that. Some people can't, which is also fine. So if I was going to use a calculator, let's say, to do that, then you're just doing 2, and you just keep doing times 2 until you get to the desired number. Remember that Desmos can be used as a normal calculator, so you're welcome to use Desmos, or if you have a Casio or a TI calculator on hand, that's fine as well. I'll keep doing 2 times 2 until I get to 16. So it'll pop out the number here for the operation. I did 2 times itself 4 times, therefore I can rewrite the right side of this equation as being 2 to the 4th power. Once I do that, I can set the exponents equal to each other, which means my answer here is x equals 4. If we were in person, we could make this a little more complex, throw in a 1 or 2 step equation up top instead of just having x, but we're trying to keep it simple here, so these are the types of problems you're going to see on 6.4. Do another example here. Let's say I have 10 to the x equals 1,000. Same thing, if you can do the mental math, that's great, or you can use a calculator. You're trying to rewrite 1,000 as 10 to some power. 1,000 ends up being 10 cubed. Once you have the same base, you can set the exponents equal to each other. Therefore, my answer here is x equals 3. So most students get along okay on problems that are like 1 and 2, and you'll have a few questions on your 6.4 assignment that look like that. What throws a lot of students off is when we get to a problem, let's say 3 to the x equals 1 over 81, where the right-hand side is a smaller number than the base on the left-hand side. Anytime you have a situation like this, what you're going to do is you're going to need to use negative exponents. This is covered in the rules of exponents video if you need to go back and review. But your negative exponent rule specifically states that if I have a negative exponent, let's say a to the negative m, that is shorthand for having an exponent in the denominator. So a to the negative m is the same as 1 over a to the m. And depending on what book you're looking at, or if you're using online resources, the variables might change, but the principle is the same. A negative exponent is shorthand for having an exponent in the denominator. So, for a problem like number 3, what I need to do then is rewrite first 81 as 3 to some power using a calculator or the mental math. 81 ends up being 3 to the 4th power. Now, some students would take this step from here and just say x equals 4. But the bases have to match up exactly on both sides for us to be able to do that. And right now it's in the denominator. Using my negative exponent rule, going backwards if you will, I can rewrite the right-hand side as being 3 to the negative 4th power because it was in the denominator. Once I do that, now the bases are the same, and therefore my answer is x equals negative 4. Similarly, let's say I have 4 to the x equals 1 over 16. Anytime that right-hand side is smaller than the base on the left, I know that I'm going to need to use negative exponents. So I would first rewrite 16 as a base 4, which is 4 squared. Then using my negative exponent rule, I could rewrite the right-hand side as being 4 to the negative 2. And then once the bases are the same, set the exponents equal to each other. Your answer is x equals negative 2. Now in all these examples 1 through 4, I'm giving you problems where your answer ends up being an integer, it ends up being a whole number. It doesn't have to be, but for your assignment, because we're trying to keep it simple, they will always be a whole number. Okay? Now the other thing that throws students sometimes is when you have a non-whole number, a decimal or a fraction, as your original base. So let's say I have 1/2 to the x equals, let's say 64. Okay. Well, here I need to take 1/2 and I need to raise it to a power to get a whole number. And basically what's going to happen here is just like numbers 3 and 4, if I'm dealing with fractions, what I'm going to need to do is use my negative exponent rule. But instead of going from a fraction to a whole number, I'm going to go from a whole number to a fraction. Okay. So first thing I'll do is I'm going to rewrite 64 as a fraction by putting a 1 underneath it. Now if I wanted to invert this, if I wanted to flip it, I would need to raise that 1 over 64 to a negative power. Right? Negative power basically flips the fraction. It moves the bottom to the top or top to the bottom or both if it's a fraction where I have both a numerator and a denominator. Now the goal is to say, okay, how do I go from 1/2 to 1/64? Well, 1 times any power is going to be 1, so we can sort of ignore that. Then what we're looking at is 2 to what power is 64? Using a calculator, or doing the mental math, 2 to the 6th power is 64. So therefore, 1/64 is 1/2 times itself 6 times, but because we started with 64 and not 1 over 64, I have that negative there. And therefore, my answer here is x equals negative 6. That's it for today, guys. If you have any questions, please reach out to me during office hours. Otherwise, have a good day, and I will talk to you soon. Bye.